Hello friends, welcome back to our YouTube channel v8i Home. Today I would be explaining you how to create a simple model in StatPro. In the previous video I had explained you about StatPro, its uses, and had given you a brief idea about the tools and menus that we require in the analysis and design of a structure using StatPro. So friends, let's start generating a simple frame structure using StatPro. First, I would click here on new project. Then I would be clicking on space. I would rename my structure as ABC. Then I've selected meter and kilonewton. Then I will click on finish. Then add beams. Now I got a geometry window in which it is showing my grid. I'll change the default grid from XY plane to XZ plane. Since we want Y to be our vertical axis and X and Z to be our horizontal axis. We can change our spacing. These spacings we can change from here. Suppose I want to do 0.5 in this side in X direction and in 0.5 in Z direction. I can do this one, but we don't need this one. So I would be setting my spacing to one back, right? Then I will be, this is my geometry plane. Okay, now I would start my first point. This would be my first point. I will click here. Okay, then I want another point in X direction at 6 meter. So I would take my cursor to 6 and click again. Then again I want another point at 4 meter, again another point at 4 meter, so it will be at 8 meter. Then I want to come back again at, I would be clicking here. Then in the Z direction I would go back to 4 meters and 4 meters, right? So guys, this I will escape here and I would select my beams. So this is a rectangle that I've make. This is a rectangle that I've make. So what I would be doing right now, I want to make one story above. So what I would be doing, I would be doing I would select this one, the whole rectangle, then I would do a translational repeat. I, I want to do, I want to do repetition in vertical axis, so I would be selecting Y. So uh, let us take my spacing as 4 meter, the height as 4 meter, and step as, let me take two steps. I would be creating two stories. Okay, first story and ground floor. So two stories. Then I would link the steps. If I tell you, if I don't click on this one, then what will happen? Suppose if I didn't click on this one, then it will uh, it will make the repetition of the rectangles without connecting them. Then I have to manually connect this one. So better use link step there. So I would be now doing undo here, Control Z. So again I would be doing translational repeat, Y 4 meters, two steps, and I would be linking each story, right? So we get this one. Now what I will do, this is our box, right? I'll take a 3D of this one. It will be like this. I'll show you the 3D. It will be like this. Now what I will do, since I don't want this one here, I'll delete this one. Now these are my columns, these are my beams. This one is the first floor, this one is the roof floor. What is missing here, guys? One beam is missing here, so I will add the beam using add beam command. I'll click here, then again here, I click here, then at the another point. So I've added two beams manually, right? Now we have created a simple model here. Now let's go to the second step. Our second step is we will go to general button. We will press the general button and we will go to property. I will not save the file. Then I will define it. Suppose I want my column to be 0.3, 300 by 300 meter, mm, 300 by 300 mm. Then I would be inputting those values here and I would add. And I want my beam to be defined. I want one more property. I want my beams to be 0.3 by y is 0.4 by z will be 0.3. The size will be 0.3 by 0.4 depth, and I would be selecting concrete. Okay, add. Right. Then I'll select the vertical members. Select beam parallel to y, and I will assign these. So you can see R1 has been assigned to these vertical members, right? Now I'll do the same thing with my beams. I select beam parallel to X, select beam parallel to Z, and I would be now assigning those beams. Right, now I'll show you the 3D of this one. It is like this. Since we have assigned the properties to each elements. Now what I will do is I'll be creating some supports. Create. I would be adding fixed support. So I'll select this node, this node, this node, this node. I'll assign, and let me create one more support. This is a pin support. This one. Let it be pin support. Right. So these are the supports that I have assigned. There are some random supports. Generally, we use fixed only. Now supports are assigned. Now what we will do is we will be putting some loads over here. So what I will do is I would be adding my load. Suppose this is my dead load. I'll add. Okay, you can add as many as load cases you want: live load, seismic load, wind load, etc. So but I want to just give you a brief about it, so I would be adding only dead load. Then what I will do is I will add self weight, right? Then I will select the whole structure. Since self weight is assigned, will be assigned to the whole structure, so I have assigned self weight to the whole structure. Now these beams have been assigned, and these beams and columns has been assigned with self weight. Now what remains here? Slab is there, slab weight is there, that I have to manually input it. So I would be selecting floor load. Then I would define some range, or we can also define group if we have made any groups. Suppose I'm making a group. I am making a group This is a new view. You can go to the new view from here, view selected objects only, right? Now I would be making a group so that I can assign my floor. We can do it with ranges on also, but I would show you how to do it with uh, group. So I've associated a group here. Now what I will do is I would create, so the group comes here. Now what? Suppose let us say our slab is 150 mm thick. So the self weight will be how much? It will be 3.75. So I would be entering minus 3.75 here. So I would be entering minus 3.75 here. Right. Now select this group. Add. See. Our floor load has been assigned to this. Now what I will do is similarly I will assign floor load here, but in this case I will not make a group. We can also make a group. I will give you another way how we can assign a floor load here. I would be using range here. First let me see what is the coordinate here. It is y is 8 and z is 8, 8, 8. Okay, add floor load. Here I will be putting minus 3.75, right? Or y is 8, maximum is 8, because we want floor load on the top, at on the top only, right? So x will be from 0 to 8 and z will be from 0 to 8. So see, we have assigned the floor load by two methods. First is by making group. The second one is by using range. You can use any of it, both are correct. Whichever you feel easy, you can use both of them. Right, this is the floor load. Similarly, different types of loads are there which you can put here. So now our modeling is complete. We have applied a property here. We have applied the loads also. Now what is the next step? Next step is to analyze it. So we would be running our analysis. We have got some error here. Finish command in load data. Okay, we have made one mistake here. We didn't add the perform analysis command. Okay, now so this is the perform analysis command which we have to add. Right, now we will do the analysis again. See, now it's running without any error, without any warning. You can see the now in the previous video I have told you that we would be landing to the post-processing page only after analysis. Now we will be clicking on post-processing. Since we have only one load, we will be selecting that one. So now we will get the results here. We will be getting the bending moment diagrams of each beams, each column. We can extract the forces from here. So guys, uh, let's finish here. This is the simple modeling that I have discussed with you today. Now, in the next video, we can discuss in more details. If you do like my video, please like, share, and subscribe. Also, hit the bell icon for latest videos. Thank you and goodbye, guys.